All right, everyone, we have 1.8 inverse functions. So to start off, our notation for the inverse is f negative 1. So that reads f inverse. So we could say the inverse of a function. Now, the first thing we're going to do is verify whether functions are inverses of each other. So if you look here, we have f inverse of f of x equals x, and f of f inverse equals x. So that's what we're going to start off first. Before we talk about doing the first question, one thing that I just want to talk about is basically that when you have the inverse, the domain of f of x is equal to the range of f inverse and vice versa. So the range of f of x is equal to the range, it's equal to the domain of f inverse. Now, the reason that I'm showing this is because there are three graphs here. And you can see functions like right here where my finger is, or my pencil is. There's f of x and there's the inverse. So for every point in f of x, that is xy, in the inverse, it is yx. You flip the coordinates. So that's why I'm showing you that. And if you look, there is a reflection over the line y equals x. So this line right here is y equals x. Y equals x. Y equals x. So that's just some basic notes on inverse functions. So the first problem we're going to do is verify that these functions are inverses of each other. So I'm going to write what was on the last slide up at the top. F negative 1 of f of x equals x, and f inverse of x equals x. So that's basically what we're going to do. With f of x and g of x, we're going to see if they're inverses of each other. So first one's find f of g. So we're going to take g of x and put it in every x for f of x. So f of g of x equals 3 times x minus 2 over 3 plus 2. Now when we simplify, 3's will cancel, and we'll get x minus 2 plus 2. We keep simplifying, we get x. So that is basically what we have here at the top, that when you do f inverse of f of x, you get x, and now we have to do the other way. So now we're going to do g of x. So g of f of x equals 3x plus 2 minus 2 over 3. We're going to simplify 3x plus 2 minus 2 over 3, which equals 3x over 3, which equals x. So since they both equal x, like the rule said from the beginning, they are inverses of each other. They are inverses of each other. So this little graphic here, it's a little blurry, but it just kind of shows you that you're kind of doing the opposite here. It shows you the changes that is happening. So over here we have a multiply by 3. Over here we divided by 3. And add 2 and subtract 2. So it's basically kind of just showing you that what's happening is undoing. whatever happened before. So it's just a nice little graphic. All right, so I want everybody to try this one on their own. You're going to verify if these functions are inverses of each other. So I want you to pause the video and try to solve them now. All right, and here is what I got for example 2. So go ahead and take a look and see if you got what I got. So I did f of g and g of x and g of f, and I verified that they are inverses of each other for my reasoning here below. All right. How can we tell if a function has an inverse that is also a function? So very similar to the vertical line test, we are going to use what's called the horizontal line test. So remember, a function provides exactly one output for each input. So we can tell if a function has an inverse that is also a function by drawing a horizontal line through. So for A, if we draw a horizontal line through anywhere on this, it's only going to hit at one spot. So this is yes. This parabola here, if we draw a horizontal line through, you're going to hit at 2 spots. So no, it does not. The inverse is not a function. For C, we can hit at 3 spots. So that's going to be no. And for D, 1 spot. That's going to be yes. So how can we tell if a function has an inverse that is also a function? We use the horizontal line test. Just a little background, so just a little example. If you take the graph y equals x squared, it's a parabola. And we look at some of the points on this. Some of the points are -2, 4. We have, what else do we have? We have -1, 1. We've got 1, 1. We've got 2, 4. Now, remember we talked about on the first slide. For f of x, the points are x comma y. For the inverse, you flip them, so y comma x. So this becomes 4, -2. This becomes 1, -1. This becomes 1, 1. This becomes 4, 2. Now, if you look, the inputs of 4 and 1 are associated with 2 outputs. The input here, 4, has an output of 2. This input of 4 here, this input of 4 has an output of -2. This input of 4 has an output of +2. This input of 1 has an output of -1. This input of 1 has an output of +1. And to be a function, remember that there can only be one output for each input. So this shows that the inverse is not a function. And if we do the horizontal line test, it would hit in 2 spots. So that is why the horizontal line test works, and that's why y equals x squared does not have an inverse that is also a function. So again, on this slide, it's just some further explanation. We've got the blue here, which is y equals f of x. So I'm going to list the coordinates. -3, 2, -1, 0, and 4, 2. When you look at its inverse, the coordinates are, oops, sorry, I should be negative there, are -2, -3, 0, -1, and 2, 4. So again, you can notice that the coordinates are flipped. So f of x is x comma y. The inverse is y comma x. You can also see the line y equals x here that we talked about on the first slide, the reflection over the line y equals x. So again, that's graphically an inverse. All right, how can we find the inverse of a function? So we're going to do it algebraically now. So the first thing you're going to do, I'm going to write the steps. The first thing is we're going to replace f of x with y. So I'm going to write y equals 7x minus 5. Now we are going to switch x and y. So now I'm going to have x equals 7y minus 5. Now you are going to solve for y. So in order to solve this one for y, we're going to add 5 to both sides. It's going to give me x plus 5 equals 7y. And I'm going to divide both sides by 7. So now x plus 5 over 7 equals y. Now it is solved for y. So the last step is to replace y with f inverse. So the final answer is f inverse x plus 5 over 7. So again, our steps, we replace f of x with y, we switch x and y, we solve for y, and then we replace y with f inverse. So now I want you to pause the video and try number 2 on the right here. And there you go. The inverse is x minus 7 over 2. All right, next two we're going to do together. See, we're going to follow the same steps. We're going to replace f of x with y. So again, we're finding the inverse. Then we're going to switch x and y. And now we're going to solve for y. So we're going to subtract 1. X minus 1 equals y cubed. Now I'm going to cube root both sides. And the cube root of x minus 1 is going to equal y. Then we replace y with the inverse. The inverse of f of x equals the cube root of x minus 1. Okay. Now we are going to do number 4. So, all right, so for number 4, we're going to start the same way we did before. Y equals 5 over x plus 4. Now we're going to switch x and y. X equals 5 over y plus 4. And now we're going to solve for y. So first we're going to subtract 4. Try to make my 4s a little more distinct so they don't look like y's. X minus 4 equals 5 over y. Now we're going to multiply by y on both sides. So now these cancel out and we have y times x minus 4 equals 5. And now to isolate y, we just divide by x minus 4. And that gives us y equals 5 over x minus 4. And then our usual last step. And there we go. All right, let's keep the ball rolling with number 5. We're going to find the inverse of f of x equals x plus 2 over x minus 3. So we're going to start the same way we usually start. Y equals x plus 2 over x minus 3. Now we're going to switch x and y. X equals y plus 2 over y plus 3. Oh, I'm sorry, minus 3. Make sure you switch both. Now we are going to solve for y. So first thing we're going to do is we're going to get rid of the y minus 3 out of the denominator. We're going to multiply both sides by y minus 3. That's going to give us x times y minus 3 equals y plus 2. Now we're going to distribute the y in. Now keep in mind, distribute the x. Now keep in mind our goal is to isolate y. So I'm going to distribute the x in. I'm going to get xy minus 3x equals y plus 2. So now, like I just said, we want to isolate y. So I'm going to get all the terms with a y on the same side. So first thing, I'm going to add 3x onto this side. So I now have xy equals y plus 2 plus 3x. And then I'm going to subtract y over. And I'm doing this because I want all the terms with a y on the same side. So I have x, y minus y equals 2 plus 3x. Now, I'm simply just going to factor out a y to get one single y. Because remember, I want y equals. So I'm going to factor out a y. When you factor a y out of xy, you get x. And when you factor a y out of y, you get 1. Now we have one single y. So we're just going to divide by x minus 1. So here I'm here at the bottom. Y equals 2 plus 3x over x minus 1. Which, again, our final step. There we go. So again, we had to do a little work for that one. So at this point in time, I want you all to try last one of the day. This one right here. We're going to do this one right here. So pause it and try to get this one done. And here is what I got for number 6. So you can pause and check. This is the end of your video notes.